Okay, so here is our study guide directions. Uh, you can either do the study guide first and then watch this video to review the questions you missed, or if you are not super confident in this unit still, you can follow along with me in this unit and just pause at the start of each individual question, work through as much as you can, and then unpause to see my explanation. Either one works, but at either way, here's the study guide. The questions were all at the top. The place to enter all of your answers was below that. Uh, just makes it quicker and easier to make this. Plus, this way, in case the internet goes down, like it did kind of today, I can print it off. Here is a link to the original PDF in case you are doing this from home and want to print it off. It's available. But we'll go ahead and get started. Number one, when rounded to the nearest cubic inch, a popcorn container in the same shape, in the shape of a cone, has a volume of 56 cubic inches. What is the height? If the height is this, what is the diameter? So, for volume of a cone, we're going to be using the formula 1/3 pi radius squared times the height. So this problem, it gave us the volume 56. And we, of course, know pi is just pi. We do not know the radius, so radius squared. And we do have the height, which is 8.5 inches. So for this problem, our goal is to completely isolate and get the r all by itself. That is our goal. So, uh, I kind of showed you before how to do this problem, but there's a much quicker and easier way, especially seeing as we have access to this calculator, which is capable of doing this calculation I'm about to show you. Our goal is to get the r by itself. R is being multiplied by 1/3 pi and 8.5. So rather than breaking this up into a bunch of different steps, let's just go ahead and divide the whole thing on both sides by 1/3 pi 8.5. We can do this and that will cancel this out. It'll cancel this out and it'll cancel this out. Now, if you're using like this calculator up here, it won't be able to handle it. This calculator is not capable of that computation. This one, the Desmos calculator, is, because what we'll type into the Desmos calculator is 56 divided by 1/3 pi 8.5. And the Desmos calculator can do this calculation. So let's go ahead and type in 56 divided by 1/3 pi times 8.5. And you can kind of see here's how that will look. In a normal calculator, they can't do fractions within fractions. Desmos can. So what we're going to end up doing is 56 divided by, and I'll kind of do that again slower so you can see exactly what I'm pushing. I push 56 divided by, and that gives me a fraction. 1 divided by 3, that gives me this fraction. I need to click out next to the 1/3, so that way I'm not typing inside that fraction anymore. 1/3, and then pi, and then parentheses 8.5. And that gives me about, I'm going to round that to 6.29. That would round down because of the 1. So I'm going to have about 6.29 equals radius squared. So now this is kind of the tricky part. We would be thinking of what two numbers would multiply together to get 6.29. So 6.29, here's the thing. We can use another symbol on our calculator, this one. This is basically the opposite of taking a square root. This and that will cancel out. So we just need to find this, the square root of 6.29. So I'm going to go ahead and type that in. We've got the square root of 6.29, which is about, can't see it, about 2.5. So about 2.5 is our radius, which is the wrong answer. The question was asking for the diameter. So if 2.5 is the radius, we would double that to get 5 as the diameter. So yeah, lots of tricks happening in that problem. Kind of started off with one of the harder problems on this. For number 2, this one is a little bit more reasonable. This one is asking us what could be the dimensions of this cylinder, assuming that the volume is equal to 1,200 pi. So we already kind of know volume of a cylinder would be just pi times the radius squared times the height. So according to this, they're not calculating pi. They're not doing anything with it. So we can kind of ignore pi right now. What we're looking for is some combination of a number squared times the height, which will equal 1,200. And we've got our calculator, we'll just start punching things in. So option A is 12 for the radius, so that'd be 12 squared times the height, which would be 10. Nope, that's 1,440, so that's wrong. We'll try B, which is 10 squared times 12. And that was it. It's going to be B. Yeah, nothing really to do with number 2 other than trial and error. Let's go ahead and move on to number 3. How does the volume of a cylinder compare to the volume of the cone if they have the same radius and the same height? So we have cylinder versus cone. Cylinder is going to be pi r squared times the height. The cone is going to be 1/3 pi r squared times the height. The only thing that's different, the cone gets multiplied by 1/3. So guess what that means for the total volume of that shape? It's going to be 1/3. So for this one, we wanted C. A cone is going to be 1/3 the volume of the cylinder. For number 4, it shows us 2 cans of corn with identical heights, but one of them has a larger radius. And it's asking us what's going to happen to the volume. So for this problem, go ahead and pick an imaginary height, really any of them. These two supposedly have the same height. I'm going to say the height is 2. That just makes it easier for us to do this calculation. So the volume of this bigger one is going to be pi times the radius, which is 8 squared, times the height, which is 2. The other one is going to be pi radius of 4. Why did I just type that? Radius of 4 squared times the same height, 2. So this one on the side, we've got volume, which equals pi. That would be 64. 8 squared is 64 times 2 is going to be, let's see, what would that be? That'd be 128. Versus this one, volume would be pi times 4 squared would be 16, and 16 times 2 is only going to be 32. We have 32 and we have 128. You could calculate pi, but really you don't really have to. You can just focus on these two numbers and think about how much bigger is one of these numbers than the other. How much larger is 128 compared to 32? Is it twice as much? No. Twice as much would have been 64, so that's not it. You can take a shortcut just by using your calculator and dividing them. 128 divided by 32 tells us that it is exactly 4 times larger than the other one. So the volume of the smaller one is 1/4 the volume of the larger can. Yeah, if I take 128 and I were to take 1/4 of that, that does equal 32. That's exactly what I wanted. And that's mostly just because uh, we don't have 4 times as larger for the bigger cylinder compared to the smaller. So that's going to be it for number 4. I should be remembering to punch these in. What did we get? We got number 1 was B, 2 was B, 3 was C, and 4 was A. So let's go ahead and punch those in. 1 was B, 2 was B, 3 was C, 4 was A. There we go. And let's move on to number 5. A server fills an ice cream cone with ice cream. Okay, so the cone has a diameter of 3 inches and is 8 inches tall. So if the diameter is 3 inches, that means the radius is only 1.5 inches. Volume of a cone is still 1/3 pi times the radius, so 1.5 squared times the height. So let's go ahead and punch all of this into our calculator and see what we get. Since it did not tell us what to assume pi is, we will use the pi symbol on our calculator. So we've got 1/3 times pi times 1.5 squared times the height, which is 8. And I got 18.849, and it continues. So this one, we're going to have to round. It didn't tell us what to round to, but since those are all whole numbers, we can assume we needed to round it to the nearest whole number. 18.8 would round up to 19. So for number 5, we get B. Let's go ahead and move on to another one. Let's see. Number 6. A cylindrical barrel holds 10,164 cubic inches. We don't need to know that in gallons. That's useless. If the barrel is 23 inches in diameter, what is the height? So this is a cylinder. We've got volume equals pi times the radius squared times the height. It told us the diameter, and the diameter, we're going to have to take that and divide it by 2. So 23 divided by 2 would be 11.5. So our volume is 10,164. We have pi, we have our radius, which is 11.5, and we just don't have our height. So if you remember a problem I mentioned earlier, we can take a shortcut. And since we have to isolate everything except one of those variables, we're going to divide everything by everything except that variable. So we got pi 11.5 squared. That is going to cancel this out, and cancel this out. But we have to do it to both sides. So pi times 11.5 squared. And since we have our Desmos calculator, it can handle it. So 10,164 divided by pi times 11 point, whoops, copy that and paste, 11.5 squared. And that should give me about 24.4. We can see the answer. The answer is going to be B. 24 inches. This would round down 24.4. That rounds down to 24. Let's see, that was B for number 6. For number 7, it says Ellis is makes and sells wood crafts. For his next piece, he needs to cut a sphere from a cube. The cube has side lengths of 4 inches, and we can kind of see how that's represented here. The side length, so from here all the way to here, is going to be 4 inches. And the question is, what is the volume of the sphere? Well, technically, they didn't give us the diameter or the radius. Also, technically, the length of that red line is going to end up to be the length of the diameter of our sphere. So if 4 inches is the diameter, cut that in half and we have the radius, which is 2 inches. Volume of a sphere is going to be 4/3 times pi times the radius cubed. So we're just going to punch into our calculator. Volume is 4/3 pi, the radius, which is 2, to the 3rd power. So let's go ahead and punch that in. We've got 4/3 times pi times the radius to the 3rd power. If you didn't know the 3rd power, you're using this button. It says A with a little b in the corner. That moves your cursor up there into the corner of the number, so that way you can type in whatever exponent you need. In this case, we need the exponent of 3. So my answer comes out to be about 33.51 something, something, something. Doesn't matter. 33.5 is an answer choice. So that's going to be C for question number 7. Moving on to question number 8. It says the radius length of, I don't know why they called it that. They could have just said radius. The radius of cylinder 1 is 3 inches and its height is 5 inches. The radius of cylinder 2 is 5 inches and the height is 2 inches. And it asks how many cubic inches larger is cylinder 2 than 1. So they're telling us this one should be bigger than this one. How much bigger is it? And this time they make a stipulation about pi. They tell us specifically to use 3.14. Do not use the pi button for this one. So we'll go ahead and get started. For this cylinder 1, we've got the volume, which equals pi times the radius, which is 3, squared, times the height, which is 5. And for the volume of cylinder 2, we've got pi times the radius, which is 5 squared, and times the height, which is 2. So cylinder 1, we'll do this one first. This one is pi, so we've got 3.14. They told us specifically to use that. Times the radius, so 3 squared, times the height, which is 5. So for cylinder 1, I got 141.3. Cylinder 2, we've got parentheses 3.14 times the radius squared, so 5 squared, times the height, which is 2. So for the second cylinder, I got 157. And the question was, how many cubic inches larger is cylinder 2? So we're going to take 152, 57, not 2, minus 141.3. And the answer is exactly 15.7. You probably would be able to get the answer even if you used the pi button, but you would have had to do some estimating at the end because you would not have gotten exactly 15.7. So just kind of be careful and read carefully. So that was number 8 was B. And moving on to number 9. For number 9, it says that he has a container whenever it gets down to 1/4 full. Uh, Okay, so he never lets it get down that far. If the gas container is in the shape of a cylinder, approximately how much gas is left when it's time to refill it? So the question is, we have to find the volume of this cylinder, and then we have to multiply that by 1/4 to figure out how much fuel is left when it's only a quarter full. So for this problem, step 1, find the volume. Volume of a cylinder is still going to be pi times the radius, which is 5, squared, times the height, which is 18. So we'll start off by punching that in our calculator. So this one, we've got pi times the radius squared times the height, which is 18. And I get 1,413 point, I'll round it to the nearest one decimal, 0.7. Okay, so that's what we have. We have this number, which is an answer choice. It's the wrong answer choice. You then have to take that number and multiply it by 1/4 or divide it by 4. Same thing. So we got 1413.7 divided by 4, which gives me about 353. So 353, which is B, was the answer we were supposed to be looking for question number 9. So do be on the lookout for that. For number 10, volume of a cylinder, this one, it didn't give us a radius. It says capital B, which that just means the area of the base or the area of that circle. The area of the circle is represented by pi r squared. So they have already done this part of the cylinder equation. This is already going to be equal to 28.26. We just have to multiply that by the height. That's all you have to do. So for this problem, we just do 28.26 times 9, and we get about, nope, not about, exactly 254.34. So number 10, our answer was D. For number 11, water tank shape of a cylinder. This one, it tells us to use pi. So we have to use 3.14 for pi. We cannot use anything else. It doesn't want us to use the symbol. So what we're going to do is we're going to need to figure out the radius, which is going to be half of this. So the radius is going to be 5 feet. The height is 3 feet. So we're going to do volume equals pi times the radius, which is 5 squared, and times the height, which is 3. So we're going to punch all this into our calculator using 3.14 for pi, using 5 for the radius squared times the height, which is 3. And we should get exactly 235.5, which is C for number 11. Number 11, we get C. Let's see, for number 12. For this one, it starts off simple enough. Tells us about a cylinder. So let's go ahead and find the volume of that cylinder. The diameter is 12. That means that the radius is 6. The height is 20. So volume equals pi times the radius, which is 6 squared, times the height, which is 20. So for this, it tells us again, use 3.14 for pi. So 3.14 times the radius squared, so 6 squared, times pi, or times the height, which is 20, gives us so the volume of 2,260.8. That's not the correct answer, because then it tells us gold has a density of 19.282 grams per cubic centimeter. So what that means for us is we need to multiply the amount of centimeters. That's what this gave us. This is 2,260.8 cubic centimeters, and we have to multiply that by 19.282 to figure out how many grams of gold we actually have. So we're going to take 2,260.8 times 19.282, which gives us a total of 43,592.7456 grams of gold. Basically, you're rich. So number 12, the answer was B, and whoever has that gold cylinder basically doesn't have to work for the rest of their life. For number, at least I think so, maybe. I don't know what the price of gold is right now. For number 13, the water cooler holds water in a cylindrical basin that has a radius of 6 and a height of 36. The cups for the water cooler are cones that have a diameter of 4 and a height of 4. If the water cooler is full, how many cones can be completely filled? So for this one, we have to find the volume of the cylinder. Then you have to find the volume of the cone, and then you would have to divide them to see how many times the volume of the cone can go in evenly into the cylinder. So starting off, the cylinder is going to be pi times the radius, which is 6 squared, times the height. And for the cones are going to be, let's see, volume equals 1/3. The radius would be 2, because that is the diameter, times the height, which is 4. I forgot pi. There we go. So let's find the volume of each of them first. Starting with the cylinder, we've got pi times the radius squared times the height, which is 36. Big number there. Then we have the volume of the cone, which is 1/3 times pi times 2 squared, and the height, which is 4. So we've got about 44,071 divided by about 16 or 17. So we're going to go ahead and divide that, and these answers are nice and spread out enough. We can just use the whole numbers. So 4,071 divided by, we'll round up, 17, gives us about 239, which is closest to option D. This cylindrical water basin can fill up about 243 cups before we run out. So number 13, we got D. For number 14, this one, it gives us a radius, gives us a volume, but not a height of a cylinder. So volume would normally equal pi times the radius squared times the height. In this case, they gave us the volume, 351.68. They give us the radius, which is 4, but they just don't give us the height. So, kind of going back to all the other problems we've done like this, we want to isolate the height, so divide by everything that isn't the height. Pi times 4 squared crosses all of that out. Pi times 4 squared. This is what we need to punch into our calculator, so let's try it. 351.68 divided by, that'd be pi times 4 squared. That gives me, that is very, very close to 7. So number 14, we're going to say the answer was 7. Scroll down, A. For number 15, says the cylinder has a radius of 4.5 inches and a height of 15. If the radius is doubled, how does that affect the original volume? Okay, so I'm not going to write out the formula because I've written it out 1,000 times in this video already, and it's already getting kind of long. So for the volume of a cylinder, we've got pi times the radius, 4.5 squared, times the height, which would be 15. And that gives me a volume of about 954. And then if I were to double the radius, so 4.5 times 2 would be 9. So I've got pi times, this time 9 squared, times the radius, times the height. And this time I got 3,817. So we can already pretty much see the volume definitely did not double. Double would be only about 1,000 something. Triple, also probably not. 954 times 3, that's only in the 2000s. Quadruple is where you multiply by 4, and yeah, we pretty much multiplied by 4 for this one. So whenever the radius gets doubled, you're actually quadrupling. The reason that happens, because of the exponent. If you double that 4.5, then what you're actually doing is you're doubling it and then multiplying that number again. The height, yeah, if you double the height, the volume is just going to double. Nothing fancy happens. The radius, it's going to be 4 times whatever it was before because of the exponent that you had. So for number 15, we got C. Nearing the end, number 16, we have a weather balloon that is a sphere. It starts off with a diameter of 8. At its highest point, its diameter is 32. And the question was approximately how many times greater is the volume at its max? So for this one, we've got volume of a sphere is going to be pi times the radius cubed. So we'll go ahead and just punch it straight into our calculator. Pi times the radius, so 8 to the third power. So at its lowest point, the weather balloon, oh, I made a mistake. Ignore that. That's diameter. The radius would be half of that. So radius would be 4, and the radius here would be 16. Almost made a terrible mistake. Some of you might have made that mistake. So we've got pi times 4 squared. Nope, not squared. Did it again. Pi times 4 to the third power. So about 201 at its lowest point. Pi times 16 to the third power is 12,867. Okay, I'm going to, all right, let's go ahead and copy this and divide those and see exactly how much bigger these are. So we got this number divided by this number. And let's see what happens. That is about 64 times greater. So by, let's see, going from 4 to 16, by quadrupling the radius of a sphere, we get 64 times the greater volume. Like I said, those exponents just change the volumes of these shapes very quickly. So number 16, we got C. For number 17, this one is talking about the volume of a cylinder, and it's asking which is most accurate. For number 17, let's go ahead and just find the volume. I don't see why we can't just do that. So we've got pi times the radius, which is 2, square the radius times the height, 2.5. And the radius is, that says 31.41 something something. So the radius is not approximately 40. It's not even close. It's also definitely not exactly 40. It is approximately 30, not exactly 30. Exactly 30, we wouldn't have all this nonsense. It would just say 30 and that's it. So for number 17, we have approximately 30. So 17 is going to be C. For number 18, it's asking for the relationship between the volumes of these two shapes. So cylinder or cone have the same radius, same base areas, the same heights. Well, we already know the cone is going to be 1/3 the size of the cylinder. So the volume of the cone is 1/3 the volume of the cylinder. Done. It's going to be D. For number 19, we've got, uh, let's see, Dominique is constructing a science project. To complete the project, she needs 2 cylinders full of liquid. Each cylinder has a radius of 4 and a height of 10. What is the total amount of liquid needed to complete this project? So we find the volume of a cylinder and then double it because she needs 2 of them. So volume of a cylinder is pi times the radius, which is 4, squared, times the height, which is 10. So we get 502, but that's only for 1 cylinder. Take that and multiply times 2. Oops, about 502. So 1004.8 would be our answer for this one. So number 19, we get D. And then the last problem, surprisingly the easiest problem, what shape would this form? If I were to cut this out and I were to fold it up or roll it up, as the case would be, what shape would this form? The answer is a cylinder. 2 circles, one on top, one on bottom, and then the tube part in the middle. That's going to be a cone or cylinder. So we get, forgot what the answer choices were. Yeah, B. And that should be it. Let me just double check, make sure I didn't make any mistakes on the study guide. Nope, those were all correct. So there we go. That is the whole entire study guide, start to finish. Uh, no, the test tomorrow is not going to be like this. It's not going to have the questions here, answer choices here. It'll actually be a normal test, normal format and everything. But that is going to be it for the study guide. I hope that this helped. If you missed any of these problems, go back and rewatch this video. Go back and double check your work. Make sure that you're not accidentally using the wrong formula. Make sure that you are paying attention to when a question tells you to use 3.15, and make doubly sure that you're paying attention to when they tell you the diameter instead of the radius. And that's really kind of going to be it. Good luck tomorrow.